Welcome back to Math Rocks with Mr. Cox. In this video, we're going to be looking at transforming functions again. In the past two videos, we've been looking at how you transform what's called a parabola. That would be the red-shaped curve here. Well, what about an absolute value graph? That would be the blue one here. Green would be square root. And then finally, we have cubic graphs also. So that would be covered in the last two videos. In this video, what's going to happen is we're going to go ahead and we're going to take a look at these two new functions. One's called a cube root and one is called a rational function. So if that sounds like something you're interested in, stick around. Let's get it on. The first function we're going to look at is called the cube root graph, and this is a graph of the parent function over here. The equation is here. There's your cube root of x. And one thing you should notice is that it looks kind of like a sideways cubed graph. So if you remember from the last video, if you have x to the third, and I was going to go ahead and make a t-table here, I would use the values, for instance, from -2 all the way up to +2. And for instance, if you took 2 to the third power, that would be 8, or 1 to the third power, that would be 1, 0 to the third is 0, and that's -1 and -8. And if you compare it versus the t-table for the cube root, is the exact same coordinates, but they've been reversed. So that will explain why it looks like a sideways x to the third graph. You should also know that the domain is all real numbers. I can write it like this, or I could write it as -infinity to +infinity with a comma and then these parentheses on the end here. And now let's go ahead and take a look at what would happen if we change our a, h, and k values. So this graph is y equals negative cube root of the quantity x minus 2 and then a -1. Let's go ahead and identify our a, h, and k. So our a is going to be the value out in front. That's going to be a -1. Our h is going to be a 2, and our k is going to be a -1. So what that does is it moves our locator point away from 0, 0, and it's now going to be at 2, -1. So that's going to be one of the points on our graph, 2, -1. So 2, -1 is over here. And then what you want to do is to find some other points is go just a smidge higher and a smidge lower and plug those in. So if I plug in a 3, 3 minus 2 would be a 1. The cube root of 1 is 1. That would be -1 minus another 1, that would be -2. So 3, -2 is going to be another point on this. And if I plug in a 1, 1 minus 2, well, that would be a -1. Cube root of -1 is -1, minus a -1 is a 1. 1 minus 1 is 0. So 1, 0 would be a point. And then what you want to do is you want to find a couple other points. It would be really nice if this just happened to be an 8 here, because I can get a cube root of 8. So if x is 10, that would make that happen. So 10 minus 2 is 8. The cube root of 8 is 2. That would be a -2 minus 1 is a -3. So I'm going to go write 10 down to 3. So 2, 3, 4, 5, 6, 7, 8, 9, 10 down to -3. And likewise, if this was a -8, that would be handy. So I'm going to make this into a -6 because -6 minus 2 is -8. The cube root of -8 is -2. And if you have a minus a -2 and then subtract 1, well, that's going to be a 2, and a 2 minus a 1 is 1. So if I go left 6, 1, 2, 3, 4, 5, 6, up 1, and then I'm going to go ahead and change colors here, and hopefully I can make this look pretty good here. But my graph is going to look like this, kind of cutting through there and then down around, and then I have arrows on the end. Domain is also going to be all real numbers. And so is range, because this graph is going forever and ever left and right, so that's why our domain is all real numbers. And likewise, it's also going up and down forever and ever. I know it looks like it's kind of going sideways, but it's going up here and it's going down there, and that's why we have all real numbers for domain and range. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. And the second type of graph we're going to look at is called a rational function. And it's a little strange, I'm not going to lie here. It introduces the idea of these things called asymptotes. More on that in a moment. But let's go ahead and take a look at it. So the function in this case is 1 over x. So there's a couple things you cannot do in math. One of them is you cannot divide by 0. So if you were to make x into 0, you would get 1 divided by 0 is undefined. And that is why our domain is we cannot get x being 0. Now x can be any other number, but it cannot be 0. Likewise, there's no way to get y equals 0 because there's no way to turn 1 over x into 0. So that would be our range. Y can be anything, but it cannot be 0. And so what happens is I've graphed a couple points. 1, 1 is right here. And -1, -1, of course, is right over here. And what the curve is going to look like is it's going to look like this curvy kind of shape down here and another one over here as well. And then it has these things called asymptotes. One of them, y equals 0, would be this line right over here. And by the way, y equals 0 is the same thing as the x-axis. And this blue one would be the other asymptote, and that would be x equals 0, which is also, by the way, the y-axis. So what happens is this curve that's to the right will get really close to 0 over here, but not quite touch. And same thing over here. As it gets smaller and smaller and smaller for x, it's almost going to touch this blue line, but not quite. And the same thing happens over here. So when you have a rational function, expect to see in two different quadrants, you expect to see these curves with these two asymptotes. Now let's take a look at, well, what would happen if we change things? So step one is always a, h, and k. So a in this case is going to be this number up top here, so that's a 1. H is going to be whatever would make this equal to 0, so x would have to be a -3 for that to happen, and then there's a 2 outside. So what this now means is we now have a new locator point of -3, 2. So I'm going to go to that point right here, 1, 2, 3, and up 2. So that is our new locator point. And what happens is we are going to have some asymptotes that go through there. So one of them is going to go straight horizontally through there. And by the way, that is the y equals 2 line. And over here, I'm going to go ahead and I'm going to make this one. Let's see what color should I make. I'll go purple on this one here. I'm going to go straight like this. Straight down, not my best straight line, but it's going to have to work here. And by the way, that is the x equals -3. So we have, once again, two asymptotes, and they are at x equals -3 and y equals 2. And then in terms of points, what I'm going to do is, if I have my x value here is -3, I'm going to go one higher than at a -2. And if I were to put in a -2 right here, -2 plus 3 is 1. 1 divided by 1 is 1, plus 2 is 3. So watch this. I'm going to go to -2, 3. So here's -2, 3. Put a point right there. Also, I'm going to go one lower than this, down to -4. Now, if I do that this time, what's going to happen is I'm going to go ahead and I'm going to put a -4 there instead. -4 plus 3 is -1. 1 divided by -1 is -1, plus 2 is 1. So now I'm going to go left forward, and I'm going to go to +1, which is right there. So now here are my two curves. One is going to look a lot like this. Hopefully yours will look, that was not my best curve ever, but it'll have to work here. And then same thing over here. This is going to get really close to that asymptote but never touch. And it's going to get really close to that asymptote but never touch. And it should be curved right in here. This is not my finest sketch ever, but I think you get the idea. All right, in terms of domain and range, whatever the asymptotes are, that is what x cannot be. So if I have an asymptote of x equals -3, my domain is, it can be anything, but it cannot be -3 because neither of these curves will touch x equals -3. And likewise, my other asymptote is y equals 2. So therefore, my range is anything, but we cannot have it be a 2. So that's it. That's how you make the last two types of functions, and how you deal with a, h, and k, whether it has asymptotes, all that kind of lovely information. So I hope you got a lot out of this video, and hope to see you again soon. Thanks for watching.